All right, hey everyone. Welcome to our third lesson of our trig unit. Your aim for today is how do we evaluate trigonometric functions? Homework is going to be in the OpenStax textbook, and as you'll see, there's going to be a lot of different questions, but it's going to be quick. Okay, they're going to be really quick, evaluating trig function questions, and we'll see some examples of that in classwork today. Okay, but yeah, page 470, numbers 34, 35, 37, 39, and then for 41 to 49, only complete the odd ones for these. That's going to be followed by page 484, numbers 10, 14, 18, 22. All right, here are your objectives for today. We're going to define the other three main trig functions in terms of the first three. Know the signs of the trig functions in the different quadrants. Third, complete a more comprehensive table of trig function values and terminal points for major angles. And fourth, solve a harmonic motion problem using a trig formula. All right, here is your aim. So I'm not going to go to the slide for this because it's going to be quick. So yeah, let me just talk about it here. Name the reciprocal function of sine, cosine, and tangent. Okay, so you might remember this from Algebra 2. If you don't, that's okay. We're going to go over it right now. So the reciprocal function of sine, meaning 1 divided by sine, like 1 over sine, is cosecant. Okay, the reciprocal function of cosine is secant, and the reciprocal function of tangent is cotangent. Okay, COT, SEC, and CSC. Okay, those are the abbreviations. All right, next, I'm going to talk about the signs of trig functions. So the following will help you remember which trig functions are positive in which quadrant. Okay, and you might remember this from Algebra 2. So quadrant 1, all the trig functions are going to be positive. And then quadrant 2, sine and therefore cosecant, right, the reciprocal function of sine, are both positive in quadrant 2. Everything else is negative. Okay. Third quadrant, tangent and cotangent are positive here in the third quadrant. And then lastly, quadrant 4, cosine and secant are positive in quadrant 4. Okay. So the mnemonic that's simply given for this is all students take calculus. Okay, so all the functions are positive here. Here it's sine and cosecant. Here it's tangent, right? Tangent and cotangent, therefore. And then last we have cosine and secant. Okay. As another mnemonic, a previous student of mine, Shake, shout out to you if you are watching this. He gave the mnemonic of at STI, they cheat. Okay, up to you which one you want to use. But yeah, all students take calculus or at STI, they cheat. Okay, whatever helps you remember. All right, next we have the signs of the trig functions in a table. So if you don't like this diagram here, you can also copy down this. Okay, so yeah, here we have quadrant 1, 2, 3, 4, right? Positive functions, all positive function for quadrant 2, sine and cosecant, as we said. Quadrant 3, it's tan and cotangent. And then positive functions, it's cosine and secant. And then negative functions, it's everything else, right? So quadrant 1, none of them are negative. Quadrant 2, it's cosine, secant, tan, and cotangent. Quadrant 3, only tan and cotangent are positive here. So everything else, right? Sine, cosecant, cosine, secant. And lastly, sine, cosecant, tan, cotangent. Okay. All right, if you need to copy this diagram or this table, please pause the video here. Okay. Otherwise, I'll be moving on to the next part of the lesson, which I believe is the table. All right, here we are. So yeah, so this is just the comprehensive table that I mentioned in the objectives. All right, so here we have a t value, right? Sine t, cosine t, tangent, and the terminal point. Okay, the coordinate on the unit circle for that value. Okay, so if you remember, sine of 0 is going to be 0. Cosine of 0 is 1, right? Remember, sine is a vertical function, quote unquote, and the cosine function is a horizontal function. So at 0 degrees, right? Cosine's value is maximized there. Sine's value is minimized. And then tangent. So tangent actually, tangent, if you remember from Algebra 2, it's equal to sine divided by cosine. So it's the ratio between sine and cosine. Right, so that's one of the trig identities, right? Tangent is sine divided by cosine, and we're going to use that here. Okay, but yeah, let me show you the solution. But well, we would have pi over 6, pi over 4, pi over 3, pi over 2, 3 pi over 2, and 2 pi. So these are the very common values for trig functions. And yeah, let me get to the table for this. Okay, so sine of pi over 6. Pi over 6 is 30 degrees. So sine of 30 is 1/2. And remember, you can derive this using the 30, 60, 90 triangle. And then for 45, you could use the 45, 45, 90 triangle. That's how we got these values in the first place. But yeah, just to fill out this table, make sure you have these values memorized. Yeah, let me get to the cosine value. But yeah, these are very important values. Okay, you're going to see that all the time in the rest of the year, and also calculus. Okay, a cosine of 30 degrees, or cosine pi over 6, is root 3 over 2. Then we have tangent, right? So tangent is sine divided by cosine. So 1/2 divided by root 3 over 2. So let me write that here. Well, actually, let me easier if I type it in. So yeah, sine. Sorry, this is loading a little slow. Divided by, I'm going to take this value. All right, so sine divided by cosine, right? So we have 1/2, in other words, times 2 over root 3. Let me copy this here. And as you'll see, right, the 2 divides out, and then we'll get 1 over root 3. But if you rationalize that, meaning if you multiply by root 3 over root 3, let me type that out here. So 1 over root 3. Sorry for the 3. Yeah, 1 over root 3, right? So if you rationalize that, you multiply by root 3 over root 3. Okay, so you get root 3 in the numerator, which is what we have here, and then root 3 times root 3, and the denominator is 3. Okay, all right, so tangent of pi over 6, tangent of 30 degrees is root 3 over 3. All right, moving on, we have sine of 45, or sine of pi over 4, is root 2 over 2. And this is where sine and cosine are the same, right? It makes sense because 45 degrees is midway between 0 and 0 and 90, sorry. And sine and cosine, as I said, is a vertical and horizontal function respectively. So 45 degrees being in the middle, right, they should have equivalent magnitudes, okay, of root 2 over 2. And tangent, pi over 4, is the sine value divided by the cosine value. Here they're the same, right? So it's root 2 over 2 divided by itself. So that's just going to be 1. Okay. Oh, so I didn't mention the terminal point, but yeah, as you know, the x-coordinate is cosine, y-coordinate is sine, so it would be root 3 over 2 here, and then y-coordinate is 1/2. Okay. And then for this terminal point, it's sine, cosine and sine, right? So cosine is root 2 over 2, as is sine. All right, next we have pi over 3. So that's 60 degrees. Sine of 60 is root 3 over 2. Cosine of 60 is 1/2. And then we're going to have root 3 over 2 divided by 1/2. Okay, let me write that here. Over 2 divided by 1/2. Okay, I'm going to skip a step. So you can multiply by the reciprocal of 1/2. That should be 2, not 1/2. There we go. Okay, so yeah. So sine divided by cosine, root 3 over 2 times the reciprocal of this is 2. Right? So we divide that, we get this. And then 2 divides out, we're going to end up with root 3. Terminal point is cosine comma sine, so it's 1/2 comma root 3 over 2. Okay, that's for 60 degrees. Next we have 90. So pi over 2, right? 180 degrees divided by 2 is 90. So we'll have sine of 90 is 1. Right? This is where sine is maximized. And then cosine of 90 is 0. This is where it has no magnitude, right? Because it's directly vertical. Tangent, it's going to be 1 divided by 0, which is undefined. Okay, so that's why you have that hyphen there. And then the x coordinate is 0 here, and then y coordinate is 1, right? Cosine and sine. All right, next we have sine of pi. Sine of pi is 0. Okay, pi is 180 degrees, so that's, directly on the negative x-axis. It's like right over here, right? So here, sine is 0, and then cosine is -1. Okay, cosine, right, 180 degrees, right? It's in the opposite direction of this, 0 degrees. So it'll be -1. That makes sense, right? Next we have tangent. So tangent is sine divided by cosine. So 0 divided by -1. So that would just be 0, right? So 0 in the numerator, that would just be 0. And then cosine, the x coordinate is -1, comma, y coordinate is 0. Next we have 3 pi over 2, which is 270 degrees. That's going to be located here. And here, sine of 270 is -1, right? So 90 degrees we know is 1, right? So being in the opposite direction is going to be -1, okay? And then cosine 270, right? There's no horizontal component here, so it's also going to be 0. And then tangent is sine divided by cosine, so -1 divided by 0, that's undefined. So we get that hyphen there. And then x coordinate is 0, and then y coordinate is -1. And then that's going to be followed by 2 pi. So 2 pi is actually the same as 0, right? 2 pi is 360 degrees, so we're going to end up at the same point, which is right here. Okay, so sine of 2 pi is 0, cosine of 2 pi is 1, tangent is 0 divided by 1, which is 0. And then the terminal point is 1, 0, right? So 1, 0. All right. So if you need this table, please copy it down here. Otherwise, I'll be moving on to a few examples. All right, so cosine of 2 pi over 3, tan of -pi over 3, sine of 19 pi over 4. Okay, so this is really similar to the question we saw in the previous lesson. But yeah, just as a recap, cosine of 2 pi over 3, so 2 pi over 3. So 2 pi over 3 is 60 times 2, right? So it's going to be 120. 2 pi over 3, that's right here. So the reference angle is 60 degrees, right? It's pi over 3. Reference number is pi over 3 here. And cosine 2 pi over 3 is equal to the negation, right? Because this is quadrant 2, and we know that, all students take calculus, so only sine is positive here, which means cosine will be negative. So being in quadrant 2, this is going to be the negative value of the cosine of the reference angle. Okay, we know the reference angle is pi over 3 again, right? So it would be negative cosine pi over 3. Now cosine of 60 degrees is 1/2. So it'll be -1/2. That'll be your final answer. All right, next we have tan of -pi over 3. Tan of -pi over 3, that's -60. So that's clockwise, remember? Okay, so that'll be right over here. And the reference number for the reference angle is pi over 3 at 60 degrees, right? It is quadrant 4, so tangent is negative here, right? So tangent is only positive in quadrant 3, so it'll be the negative value of tan of the reference angle, so -tan pi over 3. And we know that tan of 60 degrees. So you can either memorize that, or I personally just remember the sine and cosine values. But yeah, so sine, here I did it that way. So sine of 60 degrees is √3/2, and then cosine of 60 degrees is 1/2. And remember, tan is sine over cosine, right? And we're going to get √3/2 times 2, right? The reciprocal, right? So we're going to end up with -√3 as your final answer. All right, lastly, we have sine of 19 pi over 4. So this is a large t value question. Here we have, so if you remember, right, we're going to take out the full rotation. So a full rotation here using this denominator would be 8 pi over 4, right? So 8 pi over 4 is 2 pi, right? And then we can multiply that by 2 to get to 16 pi over 4. And that would give us 3 pi over 4 left over. So this is actually equivalent to sine of 3 pi over 4, right? So 3 pi over 4 and 19 pi over 4 are coterminal, which means that they share the same terminal point, right? They're at the same location, in other words. Okay, so 3 pi over 4, let's see. So 3 pi over 4 is 45. So 3 pi over 4 would be 135. That's right here in quadrant 2, like here. Okay, so this is the reference number. And the reference number is pi over 4. So sine 3 pi over 4, we know that sine is positive in quadrant 2, so it's going to be the positive value of sine of pi over 4. Sine of pi over 4 is root 2 over 2, so that would be your final answer. Right. All right, if you need any of these solutions, please pause the video here. Otherwise, we'll be moving on to the worksheet. Okay. All right. So, well, actually, let me make this bold, be consistent. Okay. I guess I can't make it bold. Let me try one more time. Maybe. Okay. Yeah, but -1/2, negative root 3, and root 2 over 2. All right. So this is the last objective, right? If you remember, it's the simple harmonic motion question. And you might see this in physics class. I mean, you might have already seen it, but maybe not. If not, then you will see it soon. So this has to do with the spring, okay? The displacement from equilibrium of an oscillating mass attached to a spring is given by the formula yt equals 4 cosine 3 pi t, where y is measured in inches and t in seconds. Okay, find the displacement at the times indicated in the table. Okay, so this is the table that you would have on the left on your worksheet, and then on the right, I just fill up, this is the answer, okay? But yeah, so here are the various times: 0 seconds, 0.25, 0.5, 0.75, 1 second, 1.25 seconds. Okay, and our job is to we actually just have to plug in these t values and then evaluate. Okay, but as you'll see, we'll be making use of these skills we learned, right? So 4 cosine 0. Cosine 0 is 1, so your final answer for the first row is 4. Next, we have 4 cosine of 3 pi, and then you evaluate at 0.25, which is 1/4, right? So remember, we're using this function. We're plugging into this function, right? So 4 cosine of 3 pi, and then times 1/4, that'll be this. And then 3 pi over 4, right? That's the second quadrant, right? That's 135 degrees. That's right over here. Okay, so the reference angle is 45 degrees. It's right here. And then, so cosine of 45 degrees is root 2 over 2, but this is negative, right? Because we're in quadrant 2. So this would be negative root 2 over 2. And after multiplying, you're going to get negative 2 over 2 as your final answer. Okay, because 4 divided by 2 is 2, right? So negative 2 over 2 as your final answer. All right, next we have 0.5, which is 1/2, right? So 4 cosine 3 pi times 1/2, so that would be 3 pi over 2. Cosine 3 pi over 2 is 0, right? So cosine of 270, right? That's right over here. So that's 4 times 0, which is 0. Okay. All right. Next we have 0.75, and so 0.75, that's 3/4, right? So 3 pi times 3/4, that's going to be 3 pi times 3, which is 9. So 9 pi over 4. 9 pi over 4, let's see. So pi over 4, remember, that's 45 degrees. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's actually going to be equal to 45 degrees. Okay, or co-terminal with that. So 4 cosine pi over 4. Cosine pi over 4 is root 2 over 2. So we're going to do 4 divided by 2 is 2, and then we get 2 over 2 as our final answer. Okay. All right, next we have 4 cosine of 3 pi times 1. All right, 3 pi, just take out 2 pi, right? So 2 pi is a full rotation, right? And then we're going to travel another pi, so we're going to end up at pi. Okay, so cosine pi is -1, and then this will be 4 times -1, which is -4. That'll be your answer there. And then lastly, we have 1.25. So 1.25, that's 5/4, right? So 5/4 times 3 pi, that's 15 pi over 4. And 15 pi over 4, well, let's think about this for a sec. So 15 pi over 4, we can take out the 8 pi over 4. So 8 pi over 4 is the full rotation, right? So we're gonna have 7 pi over 4 left over, which is what we have here. So 7 pi over 4, that's 1, 2, 3, 4, 5, 6, 7 pi over 4. That's fourth quadrant right here. And we know the reference number is 45 degrees. So this will be equal to cosine of pi over 4. All right, cosine pi over 4 is root 2 over 2, right? And we know that quadrant 4 cosine is positive, right? So all students take calculus, or at STI they cheat. So C here, so cosine is positive. So it'd be positive root 2 over 2, and then we'll get 2 times root 2. Okay. All right. From there. Yeah, so I'm gonna pause the video here if you need these answers. Otherwise, I believe there's a few more questions. All right, here we go. Yeah, so second question on the worksheet is find the 6 trig functions of each given real number t. Use the fact that tangent equals sine over cosine. Okay, so first t value is pi over 3 or 60 degrees. So sine 60 is root 3 over 2. Cosine 60 is 1/2. Then tangent of 60 is that sine value divided by the cosine value. So it's root 3 over 2 divided by 1/2. So I multiply by the reciprocal of the denominator. So that's root 3 over 2 times 2. And your final answer there will be root 3. Okay. Now, the reciprocal functions, they're going to be pretty easy, right? So cosecant is the reciprocal of sine. So we just flip this over. We get 2 over root 3. So 2 over root 3. All right, 2 over root 3. If we rationalize that, meaning if we multiply by root 3 over root 3, okay, sorry, that should be product, right? Okay. So this times that, we get 2 root 3 in the numerator, and then root 3 times root 3 in the denominator is just 3. Okay, that's your final answer for cosecant. Secant is the reciprocal of cosine, so it's just 1/2 of the reciprocal of that, which is 2. Okay, pretty easy. And then cotangent, reciprocal of tangent is 1, that'll be 1 over root 3, right? So that'll be, we multiply that by root 3 over root 3, so it'll be root 3 divided by 3. Okay, all right, that's your answer for the first part. Part B, we have 90 degrees or pi over 2. So sine of pi over 2 is 1, cosine of 90 is 0. Tangent, this is going to be undefined, right? Because it's going to be 1 divided by 0, undefined. Cosecant is 1 divided by 1, which is just 1. Easy enough. Secant is 1 divided by 0, which is undefined. And then cotangent, so I know like normally we would just do like 1 divided by undefined, right? But you know, the reciprocal of undefined, which doesn't you know, compute, we can't get a number there. But if you just verify this, so see cotangent actually in this case as cosine over sine, right? So we know that cotangent is the reciprocal of tangent. So you just flip this over. So cotangent is equal to cosine over sine. And that's, you know, another trig identity that we'll see in a future lesson. I mean, we'll establish that, right? But yeah, for now, cotangent, see that as cosine over sine. So cosine over sine, that's 0 divided by 1, right? Which is how we get 0 here. Okay. So please pause the video here if you need these answers. Otherwise, I'll end the lesson, I believe. I think that's it for today. Yeah, all right. But yeah, just remember to submit your homework by tomorrow night, and I'll see you all soon in the Zoom session. And yeah, catch you later. Take care.